out are on YouTube. So you should, if you keep the links, you should have access to them. They're not advertised. They're basic, but they're public. So they're public, but not advertised. So if you keep the links, you should be there. And then that's the other thing I'd like to do is try to organize all these presentations in some kind of web format. So a lot of things for me to kind of get set up. But I'd like to try to maintain connection with my students because one thing too is as you go off and you get jobs, you all can give me feedback on what's happening out there in the field, and that helps. I find that's actually one of my best ways of keeping up with what's going on. Is my students coming back and saying, "Hey, Rob, they're doing this new thing," and then I say, "Oh, really?" And then I go look that up and start trying to build lesson plans for it. So let's see. Let me get my program sorted out. I'm going to use namespace standard, and then let's see, return 0, and then I'm going to add functions.cpp. And a header.h. Functions.h, actually. Okay, so I'll give everyone a few seconds. Yeah, and actually, if you go to those links and then look at my channel, I've got a bunch of C++, C Sharp, and other ones there. I don't know if you can see them from there. Maybe I should just make them public. I don't know. It might be easier. Okay, so what we want to do is just demonstrate overloaded functions. So I'm going to make maybe a few functions here. So in functions.cpp, I'm going to call it something imaginative like my function. And this will be without any without any parameters. So go ahead and type those functions in. And you'll notice all three of these functions have the same name. So I'm going to I've got another poll open, so when you've got that typed in, go ahead and say, yes, you're ready to continue. Nothing on the driver yet. I just want to make sure everyone's got these three functions. And I'm going to talk about this for a second, and then we'll use them. Yep, we'll need to include it. In fact, it's not a bad idea to include it here too. You can include functions.h both in driver.cpp and in functions.cpp because sometimes you have a situation where one of your functions in your library needs to call another function library. We don't have that situation now, but it's not a bad practice to do that. And I'm going to rename that to okay, so I just need a couple more people to type that stuff in. Well, I'll start talking about this while we're here. Okay, so what we have is we have three functions, but they have the same name. Is that okay? Yeah, and why is it okay for me to have these three functions if they're all the same? What makes them different? Because they have different parameters. And so what we call this is the method signature. This methods, it's not just the name, which tells C++ what to call. It's this method signature, which is both the combination of the name and the parameters. So, given that, I'm going to go now to my driver. And I'm going to call these functions. So I'm going to call the first one just by calling my function. Let me ask you this. Does this work for me to just copy from the header to here? Can I do that? Not really, because what happens here is because I have the type here, right, it's going to, some of those people do that. It's like, oh, that's just, I can just copy and paste over. I'm going to recommend not doing that because this is actually a function declaration now. This is not a function call. That is a function call. Why is it giving me a red squiggle? Because Tim reminded me not to forget. Include functions.h. So this is a function call. So what I recommend is actually just typing out your function calls. So I can also, I'm going to call it and put in the number 5 on this one, and then I'm going to call it a third time, and I'm going to put in blah. And these will each be different function calls. So I'm going to run this initially. I'm going to hit Control F5. And you can see with the first one, parameterless one called. And with the second one, we got int parameter function called. So if I'm going to move these over here so that we can see them. So if we look at the this first function call results in parameterless one called, and then the second one calls a number, and then this third one, string parameter function called, blah. That work for everyone? Interesting. Nick, can you copy your main into the chat window? I want to see what it looks like. And then copy your .h. Yeah, that should work. And then let's see your functions. Ah. Did you have the same one over and over again? Or got it. So some things to notice here. Notice that here we have the parameter is num, but we're putting in a literal. How does it figure out this 5 needs to go into num and not go into text? Because it's an int. I'm going to do this. I'm going to run in debug mode. I'm going to ask you to do the same thing. We're going to run in debug mode, and we're going to chase these through the function calls. So I'm going to run the, so I put my stop point at line 12, or put it wherever your first function call is, depending on where you have it lined up. And then run in debug mode. Don't forget to close out the previous window. And so here we are at my function. I'm going to try to. And what do I hit to step into a function? What shortcut key? And then remember, if you can't remember, just go to debug and it just tells you. Step into F11. So I'm going to step into my function. And notice that when I went to the parameterless one, it did in fact go into the parameterless function. So it looked at that and made the run. So then I'm going to use F10 to step over. I'm going to hit the buttons because my F10 key actually stops my recording. So, and then I'm going to step over that, and we can see the parameterless one was called, and then it comes back here. So when I'm debugging my programs, one thing I do is before I hit, you know, a F10 or F11, I try to predict where I'm going to end up. And so now with my function 5, I think I'm going to end up over here. So then I will step into that function. And sure enough, I end up with the 5 with the num. And if I hover over num, I could see that the 5 that was the argument went into num, which is the parameter. That's another thing I wanted to make sure you all understood. The difference between arguments and parameters. Arguments are what you're passing in the function call. Parameters are where they end up in the function definition. Does that make sense? Does that statement kind of make sense? So this is one of the things that can be kind of confusing. Is you know, you're used to a lot of times using variables that names are the same, and main is over here, but we're really just this is why we say we're copying by value. 5 is the value of the argument. It's copied into the parameter num. So 5 is copied into num, and now if I hover over num, I can see it has the value 5. I can also see down here that num has the value 5. So that's what's going to be printed out here. In parameter function called, and I should see the value 5. And that's another thing is when you see a C out before you hit F10, when you're debugging, try to predict what it's going to say, and that will, and if it's different, then you realize, oh, I made a bad assumption, and often that's where the error would be. I mean, we don't have any errors in this one, but it just kind of shows you. So I expect to say int parameter function called 5. And yes, I got what I expected. And one final step over, I'm back over here in driver. And then I'm going to step over one more. I'm going to step into this one, blah, which goes into string. And then I'm going to step over. I expect text. This time the argument is blah. It's copied into the parameter text. And so I think it's going to say string parameter function called blah. Does that make sense? So step over one, and sure enough, it says that. I'm going to step over one more. I'm now next to return. So does that kind of clarify overloaded functions a little bit? Yeah, and like I think one of your programs you had where it had, two display result functions. One brought in a different set of parameters, and the one brought in, just a string. And so one was meant for displaying an error. The other one was meant for displaying the results. I think it was in tic-tac-toe. So if you're I've given you, I usually, if you get less than 90, I give you a chance to rework the problem so you can figure out what happened. And so for some of you, you need to put in both function calls, and then one will get just the struct and the results, and the other one just gets a string for results. And so that's what and the purpose of that was to demonstrate how these functions work. Let's do something else with this. I'm going to stop and yeah, rock, paper, scissors. And so now I'm going to try this. I'm going to say my function, and I'm going to put 7.7. What should happen with that one? There's a couple possibilities here. With this function call, it could get an error, or it might choose to run one of these. And it depends on the language. I can't always remember what happens in these instances. Sometimes some languages will implicitly convert this over, and it will say, well, I can't do this one because it's not parameterless. I can't do an int because it's not an int, it's a double. In fact, if I hover over it, it tells me, yeah, it's treating that as a double. But maybe I might be able to implicitly convert it to a string. So I'm going to run that and just see what happens. Interesting. What did it do? It converted it to an int. So it seems like in C++, and this is what we call implicit and explicit conversions. An implicit conversion means that you didn't say to convert this to an int, but it did. It's kind of the same thing as if you did this, which that's how you convert values over. But it said, I can't put it into this one. It's not really a string. This is the best one in it, and it figures out that it can send it there. Interesting. Those errors may have been a warning. In fact, I think I get a warning here too. Argument conversion from double to int, possible loss of data. Did anyone get that warning? You may look under your error list. If you don't see your error list, go to View and pick Error List. Yeah, the data loss was the 0.7. Whenever you convert a double to an int, that's called a narrowing conversion. That means we're going from a high degree of precision to a lower degree of precision. And so we will lose some precision. Yeah, so if we do my function, let's try that one. My function, and then A. That's a good experiment. We print 97. And which is, of course, the ASCII code for A. And basically what it did is, remember, char is really a numeric type. And so A corresponds to the number 7. And so that ended up being in here as it converted this implicitly to a 97. Pretty cool. Okay, does everyone feel like they understand? And if you think about it, how does the compiler know which one to send it to? What it's doing is it's not just kind of blindly going to this location. It's doing a little bit of assessment and trying to figure out which one to pick. And it's really the compiler which is kind of making that decision. When it's compiling, it says, this one needs to go to this function. Let's see. If it was, and best way to answer those is to give it a try. Yep. In this one, it called the int function. In this last one, it called the string because the double quotes make it a string. It is looking at the data type. And so when the compiler reads this part of the code, it says, hey, what is that? That's a string. Okay, that needs to go here. When it looks at this, it says, well, that's a char. I don't have one specifically for a char. So what I'm going to do is I'm going to convert it to a num. Now let's try this. Let's put void my function char character. Interesting. It's still called the integer one. What happens if I put this one first? Oh, I know why. Anyone know why that didn't work? What did I forget to do? Yep, forgot to put it in functions.h. So I got to put, oh, wrong one. This, I needed, where'd it go? Needed this one. So there are errors. Said my function ambiguous call to overloaded function. So this is ambiguous. It can't figure out the difference between these two. So that when it gets a integer, oh, I see. Okay. Actually, the ambiguity is here. It can't figure out whether to send 7.7 to the int function or to the char function. Why is that? Yeah, 7.7 could be converted to an int or it could be converted to a char. So it could send this one to either one of these, and it doesn't know which one to send it to. What if I made this 527? Would that fix it? No, but it can't convert that into a char. So what I'm going to just do is I'm going to just comment that out and then run it just to see the other experiment. And we can see here, it does figure out to send this 5 to the int function and this char to the char function. But this one, which wasn't precise, it couldn't figure out how to send it. So just some kind of interesting errors. Is it a good idea to write these functions and then kind of have like a double that just hope it goes to the right spot? Probably not. You kind of want your code to be clean and be obvious where it's going. So it would be better to have a, if you were going to be using doubles, to send something in as a double. Alternatively, what you could do is you could do this. You could say, okay, I've got 7.7, but I want that to be treated as an int. This is how you can convert a number from one type to the other. And if I do that, then that will work because I've told it to be an int, and it sends it to the int one. Does that make sense? Can I do that? Yeah, I can't do the string one. I can do int though. Okay. Okay, so let's see. What's the next thing I want to look at? I think let's take a 10-minute break. We'll restart at 12:25, and I think what I'm going to do is I'm going to go over different strategies for doing addition, or for adding up a list of numbers, for getting an average, and for finding min and maximum, and that will be useful for program 7. So we'll take a break till 12:25. Okay, I'm back. I'm going to create a new project. A C++ console application, and maybe we'll call this one stats demo, I guess. And we'll use this also to answer Nick's question as well about how to use references. And so, and you can call these anything you want. It's just trying to come up with meaningful names. So I'm sorry, I wasn't unmuted. What I said is I'm going to make a new project called Stats Demo, and we're going to use this one to kind of demonstrate some stuff that we can use in Program 7, and we'll also answer Nick's question on references with it. So again, we'll set up for a multi-file programming. No, you don't need to submit these to Blackboard. I'm just kind of ad hoc demonstrating some things that and reviewing some things here that we can use for the programs that you're working on. And I'll give it a little bit of time for you all to get set up for this new program. By now, that should be kind of a pretty standard thing. I actually want to wish You need to look up how you can set Visual Studio up to create templates so that it just opens up like that. But okay, so what we're going to do is maybe make a program. I don't want to go through and do program 7, but what I'm going to do is maybe start off with functions and make a function that will initialize an array. So I'm going to make it void an init array, and I'm going to pass in a double array, and since I'm initializing my count here, I'm going to make this a reference. So this will answer Nick's question: how to use a reference. So count. So often, in here, normally what you will be doing is you'll be opening up a you'll be actually reading a file and bringing in numbers and putting them into the array, and then sending them back through this part of the program. But for our purposes, just so we can get onto the how do we add things up and how do we do other types of things, I'm going to make this init function basically just initialize it. So I'm going to say numbers is equal to, I think I can do it this way, 1.1 10.10 comma 22.22 comma 11.12, just a bunch of numbers. Hold on a second. I get confused between 3 different languages on the best way to initialize an array. I'll do it this way. So I'll just create an array and then point numbers at it. And then I'm just going to say count is equal to 4. In fact, probably what might be a good practice here would be to declare count equal to 4 That doesn't like that. I remember if C++ doesn't like that. So count is going to equal 4. I'm going to create this array of 4 elements, and then I guess the question is will this return out of here? Yep, I need to put this in the functions.h. And of course, this is in your program, you're going to be reading from an array, and that's how you're going to get count. And you're going to be reading the values from the file into the array, and that's how you're loading it. But we're just going to use this just to kind of mock up what we're doing. And then now in driver, what I'm going to do is I'm going to create if I can do it this way. Nope. Actually, if I make it a 10, it should still work. And then I'm going to call init array. Let's see if this works. And pass in nums. I also need a variable for count. So if this works, it should bring in the array that was initializing the array, set it into this array here, and then what I will do is I will make a loop just to test if this worked. Int I is equal to 0, I is less than count, plus plus I, and then I'm just going to see out what I've got. And I'm just doing this little piece of code just to test out, Interesting. Yeah, it didn't like the way I initialized it. So I'm going to have to do it this way. And of course, like I said, this is just to get some passive value in and initialize an array, because you're actually going to do this by reading a file. Yeah, that one worked. So I'll give you all a chance to write that function out and get that to work. So let's see. So Nick, does that make sense how a reference works? So we're passing this count parameter out of this function, and to use it, all we have to do is we just by putting the ampersand, this will actually pass this variable out. This actually initializes the one in driver that's defined here that gets passed into the function. Did you have the cout part here? And then we need this loop here. Okay, does anyone need some more time to type this in? You don't, because arrays are automatically passed in as a reference. So while count we have to, I can point to it over here. While count we have to make it into a reference, since arrays are reference types, we don't have to do that to pass this reference in. And, you know, one thing with C++ is often we're doing things in kind of a backwards looking way. It's like, wait, we're passing this thing in here from main, but it's actually initializing it in the function. Why do we need to pass it in if it's going to be initialized in a function? What we're passing in is really the memory address. We need a reference for this in main, so we're going to create, when we declare something, we're not really creating the thing. What we're creating is a reference to the thing. And so we need to create the reference in main, and then we pass it to our function. Our function initializes it and loads it. And that way, when the function's done, we have an access to it in main. Does that part kind of make sense? That's one of the, it's very Yoda-like. backwards thinking we are. Make sure count is an int and I is an int. Look at your includes, could be a problem, and then look at your parentheses. You know, maybe if there's something was like that, it might give me a problem. Maybe if I have that. Nope, that's not driving it. Nope. Oh, you need I less or I less than count, not less than I count. You have this as opposed to this. Okay. Okay, so now that we have that, we know that we can get this. Let's give ourselves some problems to do. We want to find total, and to do that, I'm going to make a. We could do that here, and the pattern generally is this: we define a variable, and we set it to equal to 0. We loop through our array, and then what we do is we say total equals total plus, and the value in our array, and then see out So this is common way. It's called accumulation, and the way you do that is you start off with a variable equaling 0. You loop through your array, and you just keep adding to itself each element of that array. Does that pattern make sense? So I'm going to run this in debug mode and see what it looks like. And so right now, total isn't defined. I'm going to step over 1. Total now becomes 0. If I look at my locals down here, I can see total is 0. Step over 1 more, and num's index I should be 1.1. Total is 0, so total will become 0 plus 1.1. Does that make sense? So I should see total go to 1.1, which is the first value. And we can see, yes, it does go to 1.1. Does everyone see how total accumulated the first value from that array? Once we have that, it's just going to keep looping through. So I'm going to then do another one. I is going to go to 1. With I being 1, that's going to get the second value, which is 10.1 right here. That's total currently is 1.1, so 1.1 plus 10.1 should be 11.2. So I expect 11.2. And I recommend when you write this type of code, if it's like the first couple times you're going through this kind of thing, step through it and do what I'm doing here, is try to predict what the value is going to end up in these variables. I stepped through it. Oh, I got 11.2. So let's see, what did I have? I had 1.10000 with a little 0.1 at the end, and then I was 0.1. Yeah, I think what's happened is also it is 11.2. It's just that one thing about doubles is you often get close but not exactly. If you're getting memory addresses, well, make sure you're looking at total. Like here, you can see I'm getting a memory address for nums. The other thing too is make sure you have this index I. Otherwise, it will be adding the address of nums, not actually I. So this is what's going through each element of the array and then adding each one by one to total. And then if I keep stepping through, it'll keep adding each element of the array until it gets to the end and gives me the total is 44.5. Does that make sense to everyone? So very common pattern. Initialize something to something, loop through the array, do some kind of operation, get a result out at the end. So what I want to do next is I want this to be in a function. So I'm going to define a function here that returns a double call it total. We're going to pass in an array. We're also going to pass in the number of elements in the array. And I don't need to make this one a reference. Why doesn't this one need to be a reference? It's not going out. I just want to pass it into this function so that when I do this code, and I'm just going to actually just cut this out of here and place it inside of here. I need to make sure my array is the same name. I'm going to iterate through this array or this number of elements, and then I'm just going to return total. So notice some of the patterns here. Its return type is double. The thing I'm returning is a total, and total is a double. So when you're doing something like this, often the return type is going to be the same here, for this variable you're initializing to 0, and then you're doing some work with it and returning it. Does that make sense? Other things is we're passing in an array. It is being passed by a reference, but we're not really modifying that array, so it doesn't really matter. We do need the count number of elements in here. There are ways of getting the number of elements out of an array that are cooler. Some of you have actually found them and maybe have used them, but just to keep it simple, I'm just going to pass an integer with the number of elements into the function, and then and we're just using that pattern. So now to do this, I need a value here, and there's a couple ways I can do that. I could declare a double called total here, and because this function has a return type, I'll I'm going to pass in my array, the number of elements, and of course, I also can't forget to put it in my H file. Does that make sense? And the program works, essentially the same way. But now it's a function. Does that make sense? So that gives me one statistical function. Another one I could use is least. Again, I'm going to try to find the least of these numbers. And in this case, to find the lowest number, well, now this is a little different. If theoretically, same kind of pattern. I start off with a value here, and I'm going to put a question mark here because this is something you have to think about. I want to find the lowest one. I'm going to iterate through this, and now the way this works is you use an if statement. If the one you are on, numbers at index I, is less than lowest, and then return lowest. What do I need to do in here? So I'm going to go through all the numbers in the array, and I'm going to look, see if that number is less than lowest. So if that's the case, then the current one I'm looking at is lower than the lowest. What should I do? Well, I don't want to print out of here. I'm going to print out of main, but I do want to swap it. How can I swap it? What's the code I would write? And if you're thinking I need to do a three variable switch, I don't need to do that. It's actually very, very simple. All I need to do is just reassign lowest. Lowest is equal to numbers index I. Because that means, hey, this one's lower. This really should be that one. Does that make sense? MHM. So, I loop through the array. If I find a number in here that's lower than what lowest currently is, then I say, no, lowest needs to be that one. That brings us back up to here. Where should I start lowest? So if I start 0, what if all the numbers are greater than 0? What will I get back? Zero. And so if I'm going to, let's run that and we'll see what that looks like. I'm going to go ahead and put this one in here. And then we'll call that. Lowest is 0. And we know that that's not the lowest. Lowest really should be 1.1. So if we do 0, that ends up being the lowest one. How can we address that? Well, what if I made a really large number? Then it finds it. So I start with a large number, work my way down. What's the problem with that? And just to maybe I'll run this in. Well, no, I kind of need this to be if the number is less than this. The problem is that if I had all these numbers just for some reason happen to be greater than 10,000, that might not be high enough. Now there is one way of doing that there is a variable called max double, I think. Yeah, double max is what it is. DBL max. And that is the largest value that a max can be. And that would actually work. And you'll find the lowest one because we start off with lowest being the largest possible it could be. But I'm going to suggest a little better, another way. Why don't we just postulate that maybe numbers index 0 is the lowest number? It could be true, right? And if that happened to be the lowest, when it went through here, it would never change, which actually is the case for this one. And we could see that it finds it. But even if it was like in a different position, I'm going to cut this and place it here. And just to make it a little different, I'll put 1.2. This is in the third position now. When I run this, it still finds it. And so this is the way I recommend doing these least and max type things. Is start off with setting your starting value for your variable to the first element of the array, index 0. Then do your loop and do your check to see, hey, if the current one I'm looking at is less than this, then I know that I need to swap them. Yes, you could actually start at 1, but you'd have to make sure that your array has at least 2 elements in it. So if you did that, you kind of probably should do something like if count is greater than 1. So, so that you make sure that if good point. Actually, I think you're right. It wouldn't even. Yeah, you don't even need this because it should just not. It should not even run. So yeah, that's all you need, and that would save you a couple clock cycles. So if you want to get max, we've got about 10 minutes. How would we do max using this? What would be the change that you'd have to do? You just reverse that, and then you get your heist. So those are 3 statistical functions that you can use to get, for program 7. The big key here is basically, you can, and if you wanted to find the one closest to the average, you could do that. There's a number of different things that you can do with this. One thing that you often what you might be doing is you might actually be passing an array of if you're this may actually be a struct. If it's a struct, what you're going to find is you're just what will end up happening is you'll be doing something like that. So, any questions on how these functions work? And maybe next time we'll review structs. Does that help? Okay, well then that's all I have for today. Next time we'll review structs a little bit because that's the other hard concept that we have in this, and we'll try to get these more difficult concepts really understood. Yeah, and this will be recorded. It'll take me a little bit to convert it into a YouTube video and get that out, but it should be out at some point. Thank you very much. That's all I have for today. Maybe I'll put these on. Maybe I'll see if I can make these available online.